Hi, everybody. I want to take a moment to go over 5 types of programming errors that you might stumble upon. These are great types of errors to be aware of, and we're going to take a look at what each one looks like and maybe a little bit of how you can try to prevent some of these errors. So one of the first ones is syntax errors. If you make a syntax error, if your program has a syntax error, then that means there's some sort of mistake in the way that you've that. Written a program that doesn't follow the rules for that language. And if you have any kind of compiler that's taking a look at your program before you run it, that compiler will usually find those syntax errors. That's kind of the compiler's job, is to take a look at those kinds of things, among other things that compilers do. We also have runtime errors. Runtime errors occur there's nothing wrong maybe with the syntax of the program, but something happens in the course of running your program that causes it to fail. So one of the common runtime errors that you get is a data type. It may be, a mix-up between a string and a number. You can also have overflow errors. If you have information that you're trying to fit into a storage location in memory and the information you have doesn't fit in that location. We'll take a look at that real quickly. And then finally, rounding errors. Anybody who's ever dealt with fractions, 1 divided by 9 comes out to be 0.11111 repeating. We can't express in decimal form perfectly the fraction 1 divided by 9. There's a little something that gets lost in translation there. And in the same way, when computers which use binary numbers to do all their work, when they try and convert back and forth from decimals, sometimes they get just a little bit off. And so we need to be able to account for that. And finally, the most insidious kind of problem that we deal with, most tricky error to kind of find, is a logic error. And that's when your program is compiling fine and it's running fine. I mean, you can't really tell that there's an issue, but it's not working as anticipated. Maybe it's giving you the right looking number, but it turns out to be the wrong number, or there's some other sort of error in the way that your program is working. These can be really, really tricky to find. So let's take a look at some specific examples of each of these. So we're going to go over here and take a look at the syntax error program here. You can see it's already got issues. It's highlighted there. This program, it's just designed to print out hello world and then goodbye, and it's got some issues, again, with how the program has been written. So see if you can figure out what's going on here. I'm going to run through pretty quickly. If you'd like to pause for a moment to guess on your own and see if you can figure out what's going on, feel free to do that. Otherwise, I'm going to start looking through here. Public static void main string. Oh, yeah, these shouldn't be parentheses. These should be square brackets. That's kind of tricky. And then let's do another compile on this and see. And it doesn't like these lines down here. And sometimes if you're running in a compiler, you can actually find, it'll tell you what's going on. I've got an unclosed string literal. That's right. I always forget. I have to close that quote there. And then what else is wrong? Here's another compile. What's another error? There's a semicolon expected. Oh, geez. Yeah, no, I definitely need a semicolon there. And let's keep on compiling. And what? Now it's got 2 more errors. Wait, I thought I fixed that last line. Compilers, sometimes one type of error will hide another type of error. So this isn't unusual. I can't find print line. Oh, but my IDE is very nice and saying maybe you meant print line. That's right. I always get that mixed up. Print line and print line. And maybe this will fix those errors. Let's see if we compile it. Oh, that's fantastic. Now, just because it compiles doesn't necessarily mean it's error-free. It just means we've fixed all the syntax errors, or what we think are syntax errors. If I go ahead and run this and see hello world and goodbye perfectly. That's good. I fixed all my syntax errors. Let's take a look at this runtime error program and see what's happening here. What's going on? I've got a public static void main. I've got a scanner that's getting information in. I'm going to enter my age. That age is going to go into a double. Well, this is a little bit of a mistake there. That should probably be next double. Yes. And next year, you'll be age plus 1 years old. I like that. And this program, at least under some circumstances, I think is probably going to work just fine. If I enter your age, 12, and I hit enter. Next year you'll be 13 years old. That seems like that's working okay. If somebody comes along and does something a little unexpected, however, and this can happen, enter your age 13, and I enter in a string accidentally, then I'm going to get that runtime error, and it's going to let me know there was a problem with the data input mismatch exception. So that's a common type of runtime error that you just need to be able to be aware of. Yeah, hopefully that won't happen too much. There are ways to avoid those, to check for those. You can use error trapping in your programs to some extent to say solve some of those issues. Let's take a look at overflow errors. Here's an interesting little program. This program is just a demo. There's no little inputs here, but we're going to save the value 100,000 in 100K, and we'll print out how large is 100,000, and it looks like we're going to print out that 100K value just to check that that's working okay. Then we're going to multiply 100K by 100K and save that in a result variable, and then we'll print out how large is 100,000 squared and print out that result. So when we compile that, it works fine. It follows the rules of Java. That's good. But when we try to run that overflow error program, we end up getting some interesting results here, and they're hidden back here. How large is 100,000? 100,000. How large is 100,000 squared? What? That's not right. So this issue has arisen because we are trying to save a very large value into an integer variable. And that integer variable can only handle a certain amount of information. It clearly can't handle all the digits that are part of 100,000 squared. So you need to be aware of this kind of thing. Ways that you can fix this is you can say, well, there's a long integer type that is able to handle more information in there. So if you compile this and then run this, we can try and see what's going on with our overflow errors there. And get this out of the way. And where is my output? There it is. And is it still having an issue with that? Did I have an issue with that? Let's see. Long result. Yeah, I should be able to get 100,000 times 100,000. Oh, it may be that in the process, yes, in the process of doing this multiplication, this is going to give us an integer result. So not only do we have to make the long result equal to a long value, but we need to make this equal to a long value, because when I multiply two longs, I get a long as a result. If I multiply two ints, I get an int as a result. How would you know that as a new programmer? You probably wouldn't. So this is the source. This is where, writing programs as a new programmer can be really interesting and challenging / frustrating. So yeah, let's try running this one more time and see what we come up with now. When I run this, I get the answer that I'm looking for. Great question. Why don't we just use longs all the time? Because we don't typically need to have super long integers. Usually the int value that we're working with is just fine. And the int value does take up less memory and is faster for the computer to calculate with. So we don't typically use longs, but if you're seeing weird results there, if you're testing and you see strange results and you're working with large numbers, then this is definitely something that you need to check on. Yeah. What about rounding errors? These are fascinating, fascinating. So rounding errors, take a look at this here. We've got our, we're going to have a value, 4.35. We have a factor, 100, and we're going to multiply the value times the factor. You can do that in your head. That's 435. And I'm actually saving that 435 in a variable called expected. And so when we run this, let's take a look and see if we can figure out or anticipate what we're going to be seeing here. When we run this, I'm going to say we expected to see, and then over here, this is, we're printing out expected, which is that 435. We got, and it's going to actually print out the result that we got. And of course, we're expecting 435, but I'm anticipating that there's going to be an issue. That's why we chose this for this example. And here's the trick. If maybe I'm writing a testing program for my students, if I say, if the result equals the expected, if what you got equals the 435 that I was expecting to see, then yay, you get all the points and well done. If those are off, then my naive computer is going to say, well, we got it wrong, maybe because of rounding. So let's actually just take a real quick look at that. Let's run that and see what happens. What happens when I run that rounding errors program and see. And we'll take a look at the first few lines of output here, and they're hiding back here. And yeah, they're really hiding back there. Where are they? Can I bring them up here? There it is. Expected 435.0. We got 434 point blah, 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 blah. Again, we're off just a little bit, kind of like the way that 1/9 is off from the actual value when we do fractions. We got it wrong maybe because of rounding. We were really close though, enough to call it correct. So let's see how you can do that. What my strategy should be if I think that we're looking at a double value, a value that has a decimal place in it, and I need to account somehow for that decimal place. So one of the things you can do, a strategy that you can do, a strategy that I use when I'm trying to make sure that I'm correctly grading my students' work, is you can create this constant, and we sometimes call it epsilon. That's kind of a standard thing to call it right there. Create the constant epsilon, and that's a really small value there. This public static final means it's a constant. We're not going to be changing it. And kind of by convention, we capitalize the whole word there. It's a double value. And so what am I using that really small value for? Well, what I do is I compare down here. If I want to check to see if you got the right answer, I take the absolute value of your answer minus what I was expecting. And if those things are really close, if the absolute value of the difference between those two is less than that really tiny number I put up here, then I'm going to call it close enough. I'm going to say you weren't off by a tenth or a hundredth or a thousandth. You were off by some really, really tiny number, and I know that tiny number could have arisen because of this rounding error process. So even though these may be numerically slightly different, if the difference is less than that tiny value there, I'm going to call it good enough. And I'll say that you got the right answer there. So that's a strategy for using or for handling rounding errors. And then finally, let's take a look down here at logic errors. Oh, so tough. So here you can see that I've written a static method called square. And all square does is it returns whatever value gets sent in. It returns the square of that. Now, of course, in this example here, I mean, I say that, but in this example here, look what's happening. I'm not returning the square. I'm returning n times 2, not n to the second, but n times 2. That's wrong. That's incorrect right there. Wrong. And my problem is, if I were to write this and maybe even test it a little bit, I might not know that there's an error there. So for instance, let me run logic error here, the main here. And let me find my results there. The square of 2 is 4. Well, that's correct. That is. Maybe I use that as my real quick and dirty test, and the square of 2 is 4. But that's just because 2 squared and 2 to the second are both 4. The square of 3 is 6? No, that's not right. The square of 3 is 9. So what happened there? I've got a logic error. It's not a syntax error. My Java is impeccable. It's not a runtime error because the program doesn't blow up and doesn't give me any errors in the output. What it does is it gives me unanticipated output. And it can mask as, because I don't get any obvious errors, it can mask as correct output. You have to run tests on this to make sure that it's working the way you expect it to. And clearly we do have some sort of logical error in our program. It's not working the way we anticipated. It may be working correctly according to the code we've written, but the code that we've written is wrong. Those are the 5 types of errors that you can run into when you're programming, especially in Java. And so make sure that you're familiar with each of those. It'll help you become a better programmer, and it'll help you debug your code more quickly if you can figure out what kind of error you're trying to track down.